This is the program for demonstrating adding any integer in binary. Okay, we are adding integer into the string. So we just append a base 10 integer here. That's the I counter in base 10. In base 16 it's written as whatever it says. 23 is 0017, 0x0017 in base 16. In binary it's 0, 1, 0, whatever. So this works for any binary, any number for any base between 2 and 35. Base 2 will give this, base 16 is this, base 10 is this, or base 11, base 3, whatever you want. Same thing. Okay, so from the standard string, we have string create, string reverse range for later. String make empty, just so we can know where we're starting. String append character. Because we are adding individual characters here, we have two append functions, basic append for a string and then append for integer. So we put append character just to keep everything clean so we don't have to repeat this code several times. So if the string length is less than string size, it adds the character plus the null character and then increments the string length. Simple as that. Okay, append now uses a string append character. Okay, to append to the integer, we need a value, the value we're adding, the base that we're adding from, and the number of characters that we need to add. Like here, we make it 8 characters, so it adds 8 characters no matter what the number is. So it just pads the others with zeros. For here, we need 4 characters, so it just pads the rest with zeros. Okay, the way it works right here, while the value is less than while the value is it does not equal 0, we add a character that is the value modulo the base, the corresponding digit, the value. No, so if we are adding 35, so this value right here is value modulo base 35 base 10. So it's 35 divided by 10. The remainder is 5. So the first character it adds is 5. So it adds the character 5. So it adds number 5 into the string, and then it remains 30. So you take the 30 divided by 10. That's here. You take the value divided by the base again, divided by 10. So you add a 5 into the string, then you left with 30, and you divide it. Well, actually you're not left with 30. We just add the 5, and then you divide it, and then you leave 3 point. Actually, you leave 3.5, but since it's an integer, so it equals 3. So you add the 30, then you take the 3 divided by 5, take the remainder 3, the 30 divided by 10, and you take the remainder 3. So you add 5, then you add 3. So that's why you have to reverse it, because the operation here, value modulo base, it takes the last digit divided by the base, the remainder after we divide by the base. You take the remainder after divided by 10 will be 5. 3 divided by 10 it will be 3. So it's 5, 3 reverse, so it equals 3, 5. It's the same thing for any length of numbers. If we have to go above a base above 10, we use letters instead. Okay, that's it. So that's why you have to start of the string. It is starting position that we are starting. It is the position we are starting from plus the number of characters we have added. This right here, it takes the weight and just adds zeros. So it's 5300, 5300, and then we reverse it. 5300 reverse equals 0035. So that's why we need to reverse it. So once again, we take the value modulo the remainder. We take the 35 modulo 10 equal 5. So we take the fifth digit here. Now starting from the fifth, starting from 0, 1, 2, 3, 4, 5. So it's base 10. So 5 will be the 6th digit. So it's because it's 0 base, so it's 6 digits, 5, and then we put it in the buffer, and we divide this by the base, which makes now 3.5, which is 3. So divide 3 by 10, so it's 0 modulo 10 equals 3. So it's 5, 3 reverse, so it's 3, 5. Okay, so we just append the characters here just to make sure. If we value starts at 0, then this will not work, but it will still add a bunch of zeros. So that's why this works. And then when we're done, we reverse the number inside the range. Okay, this is what we are adding here. We make the string empty for I equals 0 to 5. We make the string empty, and we append an integer of I, which is which here is 0, to base 10, with a length of 4. That's what this is here, with a length of 4. Uh, we had 4 digits, 5200 reversed equals 0025. Then we append the main string 1, which is in base 16 is 0, written as 0x something, in base 16 written as 0x, and then we add the same number again in base 16. That's the equivalent base 16. And then we add a second string in binary, and then we append the same integer again in base 2, this time with 8 values, with 8 spaces. We should have put a B here just to indicate that it's binary, but that's not important. So when you add it, we print the whole thing and repeat. Make the string empty, add everything here, repeat for 0 to 55. That's it.